So, good afternoon. My name is Tamae, and today I'll be presenting the solution for our problem 11, Hygrometer. So here I have the statement of the problem. It asks us to investigate the accuracy and response time of a simple hygrometer as a function of the relevant parameters. So here is the summary of my presentation. I'll start with the microscopic view to see what interactions makes the hair to start to expand with the humidity. I'll explain my hygrometer, then I'll do a theoretical analysis about the hair expansion and response time. Then I'll analyze the accuracy and response time of my hygrometer, and then finish with my final considerations. So here I have a photo of in an optical microscope of the hair, and here we can see that the hair is divided in three different structures. The first structure, that is the most external structure here, is the cuticle that covers the hair. Then we have the internal part of the hair, that is the cortex, and then the most internal part, that is the medulla of the hair. And we know that the part of the hair that is responsible for its expansion is the cortex of the hair. So in relation to its hierarchy, we know that the hair is formed by keratin microfibrils, and these microfibrils are formed by alpha-helices structures. And in these alpha-helices structures, we have the association of hydrogen bonds here. And in these hydrogen bonds, when we have interaction with vapor water, we see the formation of different hydrogen bonds with water intermediating it. With these interactions, we see the expansion of these alpha-helices structures, and in a microscopic view, the hair expands. So here is the representation of our cell. So it is composed by a spring, the hair, a stripped paper associated with an infrared sensor. When this hair expands, the wheel spins, and the stripped paper passes through the infrared sensor that reads this motion, and with it we know the variation of the humidity. So here we have the more precise view of the stripped paper interactions with the our sensor, and when the stripe passes through the infrared sensor, we see that we capture electrical pulses that makes us able to identify the weight, and with it identify if the hair is expanding or if it is contracting. So here we have our hygrometer. Our hygrometer is divided in two different setups. The first one is the hair swell detector. As explained, we have here the hair associated with the wheel, and here we have the stripped paper. With it, we have the infrared sensor, and attached to it, we have the electronic circuit that converts these electrical pulses to a computer. So here we have the Smith's trigger, that is basically a circuit that has hysteresis to avoid external interferences in our measurements. Then the data is converted to a free-scale board and then to a computer. So in relation to the hydration reaction, we say with these variables that increase in the length of the hair is proportional to its own initial length and coefficient and the variation of the concentration. With it, we can then integrate in both sides, and with it, find the final formula for the expansion of the hair as a function of the initial conditions, its initial length, and the coefficient. With it, we could then calculate the angular variation, the angular displacement of our wheel with the previous formula, and with it we could then calculate the relative humidity as a function of this angular displacement. So knowing that our stripped paper, knowing that our sensor reads the displacement as a variation of stripes times the density of stripes per rayon, with it that's the way the sensor reads the displacement, we can then find our final algorithm that we will play on our computer to try to read the relative humidity as a function of the relevant parameters of the problem. In relation to the precision now of the hygrometer, as the problem stated when we initial analyze accuracy, we then know that we can write the displacement, the angular displacement, in two different ways. The first way, in terms of the hair angle displacement. So as the hair swells, we have an angular displacement, and the second one is the way that our sensor reads it. So with it, how do we would increase the precision of our hygrometer? We need to increase the value of the number of strips that are red in an expansion of the hair, and with it, increasing this number of stripes that are red, we can then have lower intervals between the measurements, and with it, we can increase the precision of our hygrometer. In relation to the response time analysis, we can use the fixed second law of diffusion to try to characterize the diffusion of vapor water inside the hair, and with it, knowing that the hair is a cylindrical is in a cylindric format with a radius that is much smaller than its length, and knowing that the phenomenon is symmetrical in the theta coordinate in the cylindrical coordinates, we can then approach to this formula. Then, by ansatz variable separation method, we can describe the a function as a function only of the time, with it knowing that u is the solution for the Bessel equation of order 0. So with it, setting all the boundary conditions of our system, we know that we can dominate alpha n as the solution of our Bessel function, and we know that the concentration will be described by a constant times the solution. Then with it, developing the equation, we can then find the final form of the concentration as a function of time, and with it know the angular displacement as a function of time to know response time, and with it we can then investigate all the two parameters asked in the problem. So in relation to the Rauland parameters, for the precision, we need to increase the value of the density of strips per radian to try to increase this precision. Then we need to increase the initial length of the hair to try to increase this variation, decrease the radius of the cylinder of the wheel that is attached to the hair to try to increase the angular displacement, and increase the coefficient beta, that is the coefficient of Hygrometer expansion. Increasing this coefficient, we can then increase the expansion of the hair and then increase the precision of our hygrometer. In relation to the response time, we need to decrease the hair, the radius of the hair to increase the response time and increase the diffusion coefficient. Here we have our experimental setup. We've used a cooler and in a chamber and the DHT22 to try to measure the humidity directly. And we used a humidifier to humidify the environment and the dehumidifier to try to dehumidify the chamber. So we've tested with 4 different hairs in this case. So we used the black, the brown, the blonde, and the curly brown one. And with it, we measured the coefficient of expansion for each one of them. And with it, again, as said, we need to increase the value of beta to have a greater variation and try to increase its precision. So we see that the best hair in this case is the curly brown hair, and that's the hair we will use to the next experiments. In relation to the hair variation, so we can see our experiments here. We try to measure the humidity with our hygrometer using these 4 types of hair, and we see that the increase in precision follows the increase in the coefficient beta, and with it we have more approximate measurement with our directly measured humidity for the curly brown hair. So we conclude that that's the best hair for the hygrometer. In relation to the length variation, as I said, the initial length of the hair is important to increase its precision, so as we increase its value, we have greater variations, and with it we can increase its accuracy. Again, we try to vary the initial length of the hair in these conditions and try to see how it would behave. So here we have the systematic error of our hygrometer, and with it we can see that as we increase the initial length of the hair, we have a decrease in this error, and we can see more approximate measurements with our directly measured humidity of the DHT22, and here we can see that as we increase we have more accurate measurements. So we conclude that the best hair is the hair with the greater initial length. We try to vary the number of strips per radian, the density of stripes per radian, to try to see how it would affect the precision of our hygrometer. And we could see, again, using the curly brown hair, that if we increase the density of stripes per radian, we then reduce the systematic error of our hygrometer, and with it we can increase the precision of it. Again, we try to vary the number of stripes per radian, and with it we could see, again, that this measurement becomes more precise and more close to our directly measured humidity when we increase this value. So we have more accurate measurements in this way. Now, knowing all the parameters that optimize our system, we can then optimize the accuracy of our hygrometer and have more detectable variations of humidity to try to have more accurate measurements of the humidity of the hair. So we try to compare from 5% to 90%, that is the range of humidity that we could control in the chamber, and with it we measured the differences between with our hygrometer and the directly measured humidity, and we see a great experimental agreement with all the measurements we see here. In relation to the radius measurement of the hair, we measured the radius with the diffraction method. We put a distance of about 5 meters to try to measure the between the light and the wall to try to see to measure the radius of the hair. So here I have the measurements for 4 radius. Then we try to vary the humidity to see how it would behave in the response time. So from 5 to 90%, we know that decreasing the radius, as I said, we have a decrease in response time, and we see a great experimental agreement with our theoretical curves. So the fixed law of diffusion was enough to characterize this response time, and we see a great experimental agreement with our hygrometer. As we increase the radius, as I said, we increase the response time of the hygrometer. In relation, we try to do the inverse. We try to do from 90 to 5%, and again, knowing that when we decrease the radius, we decrease the response time, and again, we have the same conclusion that increasing the radius of the hair, we have an increase in its response time. So we can then conclude that we had a great experimental agreement with our theory, and then we could see then that both accuracy and response time could be investigated. So, summarizing my presentation, I presented a microscopic view of the hair and its structures. I presented my hygrometer and its mechanisms. I've done a theory to try to model the expansion of the hair, analyze its accuracy, and I had the great precision, optimizing the conditions, and try to analyze the response time as a function of the radius of the hair. So here we have the statement of the problem. It states that we need to investigate accuracy and response time. We say that the test is solved. So we've investigated all the relevant parameters that try to optimize it, to try to optimize both conditions, so the test is complete. Here's all my bibliography. This is my special thanks, and thank you very much.
Thank you.
Hello, I'm Coleman, and I have some questions to ask for the report. So, in your theory model, you talk about the precision, yes, but in your experiment about accuracy. So, what is the difference between precision and accuracy?
Yes, we would see like the
just in short.
No, it's really small. The difference we consider like precision would be how accurate you could go to the
measurement, and
the other is related to the systematic error.
They are the same or not?
Huh?
You believe precision and accuracy are the same or not?
It's quite not different. I don't think so.
Okay, so do you process your hair when you have a hair? Do you
process?
Yeah. Do you put it in some chemical or something?
No, we clean with water and alcohol. That is the normal procedure.
Thanks. Could you turn to page 24, please?
24.
Yes. So how many times do you do your experiment?
Each one was repeated about 20 to 15 times.
15 times. And do you use the same hair or you're changing hair?
No, I changed the hair.
Okay, thanks. And so could you show us the function as relevant parameters? Because according to your policy,
function
do you have function
yes,
of?
As I shown in my theoretical explanation, as we increase the value of delta n, we would increase the precision. So that's the basis, the theoretical
function as relevant parameters.
I remember the slide 15, I think. No, the set.
Could you explain in your function how the parameters will affect the accuracy and the response?
Yes. Here's the formula, and then the next slide, going to slide 21, I think. 21. Here we've listed all the relevant parameters. The relevant parameters here. In the basis we used our formulas, and then we listed our relevant parameters to try to optimize our conditions.
Thank you.
Hello everyone, I'm Napoleon from Team Taiwan, or so-called Team Chinese Taipei, and today I'm going to opposing on problem number 11, hair hygrometer. This is a problem statement, and it told us that a single hygrometer can be built using human hair. And what we are going to do is to investigate its accuracy and response time as a function of relevant parameters. Here are the structure of solving a problem that the opponent believe. First, reporters are going to make hypothesis how hair could be a hygrometer, how humidity can make it have elongation. And later, reporters are going to define what is accuracy and response time and test each of the parameters in order to get approach about write down the function of relevant parameters about accuracy and response time to fulfill the task of the problem statement. Here are points coming from the reporter. Some opponents think they are strong, and however some are weak. And for the strong points, that reporter have tested several parameters, and he has well done experimental setup to magnify the elongation of hair so that he could have more clear record of the humidity. And for weak points, the report didn't really talk about the mechanism of how hair to be enlarged when it is exposed to a high humidity. And about the definition of the accuracy, I think that reporter might misunderstand, because in a theory model, it talks about precision, but in an experiment, it talks about accuracy. And we know that precision and accuracy is not the same. And for a theory model, he didn't directly have explanation of why for different colors of hair would be different. And here are some points that the opponent want to discuss with the reporter during the following minutes. And for first about the theory, because in this problem we need to clarify the mechanism of hair elongation. Is there a chemical reaction or something to have the elongation? And for the definition of response time, because the reporter didn't really show a clear definition of response time in his experiments. So the opponent wants to clarify this. And about experiments, the opponent wants to ask about the size of the environment, because we can see that there is a box and the reporter put the hair hygrometer inside it. And because the environment will influence the water spray and distribution. So do you make sure that the distribution of water vapor is the same in your box? And for the higher hair properties, the reporter talked about that he used alcohol to clean the hair. So when alcohol influences the properties of hair, and we all know that the hair is protein. So when it is out of human body, it will start to decay. So how will the decay of hair influence your results? And about finally the result parts, accuracy, not precision. I think the reporter really misunderstands these two different words, and so the opponent wants to clarify what is true accuracy in his experiment, and how is the accuracy and also a response time as a function of relevant parameters. And the opponent wants to skip to the discussion with the report. Yeah. So first we want to clarify the mechanism of hair elongation.
Well, yeah. Again, as I explained in my qualitative analysis, which part of the mechanism of the hair elongation you didn't understand, because I said that we have interactions between water and hydrogen bonds, and with the reaction of these hydrogen bonds with these interactions, we have then the elongation of the alpha.
Could you show like a graph about the time versus the elongation of hair?
No, we didn't measure the elongation directly. We've measured the angular displacement. We did directly.
Okay, displacement. So it's okay. Time versus the displacement. I want to the different time versus the. You know that the hair will.
Yes. But we click we throw directly in the relative humidity algorithm. So we didn't plot directly with the elongation of the hair. We plot with the relative humidity.
So in this graph, we can see that as a time sequence goes by, the hair is not have the same ratio of enlarged. So could you explain why? Well, at first it's enlarged.
Because we are increasing the radius of the hair, and as I said in my explanation,
okay. My question is in the same line. First it enlarged quickly, and first it not
because
like
as we have, for example, discrepant, really different gradient between water vapor in out the cylinder and inside the hair. We have that the diffusion will be faster, and then as the gradient becomes smaller, the time of response.
Okay, so what your point is that the vapor difference inside the hair and outside hair make outside hair got into the hair and for some hydrogen bomb or make some hair inside outside hair, the water go inside hair.
Yes.
Because there are humidity difference.
Yes.
And make some hydrogen bomb or something to make hair become longer.
Yes, that's the explanation that I gave. I didn't understand the question.
So the water outside will come inside to the hair.
Yes.
So do you have experiment to prove that hair outside hair actually go inside to the hair?
The interactions of water are with the cortex and are in the internal part of the hair. So
Okay, so here's opponent's suggestion. Maybe you need to test the weight of the water to make sure if the outside water really inside to the hair.
So in your opinion, so which concept would you see that it's better, abstraction or absorption?
I mean that if your theory model, if you want to make sure your theory model is correct, you need to weigh the weight of hair to make sure if the outside of the water is actually inside to the hair or not.
Yeah, we have some papers that actually.
Okay. I think that's enough. So could you give our definition in your experiment? How did you define the response time?
Yes, and we defined the response time, the time that it takes for our hygrometer to catch the measurement, directly measured humidity in its systematic error. So for example, if we have the increase of the measurement as a function of time, if the error already covers the measurement of the directly measured humidity, we consider it as the final point of the response time.
So what you mean is that you put the hygrometer inside your space, and from the time to the hygrometer get the actual value of the humidity. Is that the definition of response time?
That's what we've got as the definition of response time.
So did you consider your electronic hygrometer as response time?
Like the delay of the measurements in the hair and the measurements that are going to the computer, it's not comparable, it's not in relation to the response time of the hair itself. Okay, so we've just considered the response time of the interaction of the hair during the time the hair needed to react with water, and then get to the humidity with measured direction.
So could you explain your size of environment? Do you make sure that the water...
Size of environment? It's about the spread. Yeah, as you see in my experimental setup, I've used a cooler. So with or without the dehumidifier, we've used the cooler to try to spread this humidity in the environment, to try to have a uniform distribution.
Do you make sure that in this environment the distribution of water is the same?
Yes, with the cooler.
How can you make sure?
Yeah, because we maintain the air circulating in the chamber in this way with the cooler. So with it we could then spread the humidity.
Maybe the opponent believes that maybe you need to put like 4 or more electronic hygrometer to make sure in this environment the distribution of water is.
As I said, this is not necessary as we've used the cooler. With the cooler, we could then spread the humidity uniformly inside the chamber.
But just as you talk us about water have the diffusion, so it won't at first at the same. So it will come at some points and to fulfill all of the environment. So what the opponent think, maybe you need to test if the distribution of water is the same in this case or not.
No, in our opinion, that's enough. We've used the cooler and the humidity was spread already enough. And
this is just a suggestion.
So I disagree with you on this point. So
and about the hair properties.
Hair properties, you mean why dehydrating with alcohol?
Yeah, why do you use alcohol?
Yes, we know that hairs today, if we take hair anywhere, we have, with the chemical products we use in daily life, we have some layers of oil that remains in the hair.
There's some grease.
And the alcohol is to clean this layer oil to try to avoid other interferences of other chemical substances.
But won't alcohol to make the hair properties be different?
For example?
Maybe it will to harm the protein structure of hair.
The cuticle of the hair?
Yeah.
Yes, that's why we don't clean with 100% alcohol. We have a mixture of a percentage of alcohol with water, and we minimize the damages, and it's the precise enough to try to clean this layer of water and.
So you will make sure each time you do your experiment is the same procedure of to dealing with
yes,
hair.
Yes, we use the same concentration for all the experiments we have.
So will the hair properties be fatigue or creep or something during your experiment?
Yeah, that's why we've changed the hair to try to avoid extra effects, fatigue of the hair.
And you mean that you use the hair for one time, and for the other experiment you change the hair?
Yes.
To avoid the decay of the hair.
Yeah, or it sterilizes of hair.
Okay, thanks. And so could you
yes, in relation to the results,
could you clarify what's the difference between accuracy and precision?
Yes, I'm sorry. I think that there was a misconception in this point, but in relation, you want me to define both, or?
Because in your third model you talk about the precision of your hygrometer, but the task is accuracy, and we know that accuracy and precision is two different things.
We need to say that they are different, but they are kind of correlated. So we can see in our measurements.
What means they are?
We see in our measurements that we try to do both things, and in relation to its accuracy, we see that it's really accurate in relation to the directly measured.
I draw a graph, and you can see if I'm correct or not. Okay. This is a target which comes from the experimental, which comes from theory model, and if you have this kind of graph, the average will like this, and it is accurate, but not precision.
Okay.
And for another condition, this is a target from theory model. And you have
if you put
all the data like this, it's not accurate, but it's precise.
Yes, we see that in our comparison again.
So
in the last experiment, I've done with precision. Yes. No. The first experiment of precision. We see the measurements with the directly measured experiments with the hygrometer and with the ones measured with the hygrometer, and we see that its accuracy is really good in these cases. Like we've tried to investigate precision also to try to avoid its systematic error also, but we see that its accuracy that correlated with, and we have then really proximity with our directly measured.
So could you simply tell us what is your definition of accuracy?
Yes, accuracy would see the proximity between your, for example, our hygrometer with the directly measured hygrometer, and the precision would be like its systematic error, how distant from the humidity would it be.
Okay, I think I get your point.
Okay.
And so could you show the final function of relevant parameters? Could you show a function?
Yes, I've shown in my theoretical analysis the function.
Could
and
you,
I said to
what I want is, could you explain what is the other parameters in your function and how will it influence your
result? Yes, of course. In our theoretical analysis, as I said, the function of delta n, we need to increase the value of delta n to try to increase its accuracy, and with it, again saying, with this increase we can then show which parameters are related for delta n to increase, and with it we can then define all relevant parameters.
So you say that different types of hair will have different results?
Yes, for example, you may like changing the color of the hair. Yes, changing the color of hair, we change the concentration of melanin in the hair, and with this change of concentration, we have this change, for example, of the number of interactions of hydrogen bonds with water that change the coefficient giga, the expansion of the hair.
Coefficient.
Thank you.
Yeah.
Okay, I think that's enough. Here, the opponent wants to summarize the discussion with the reporter. First, about the scale of the weight of hair, because the reporter believes that the hair elongation of hair is because outside water comes inside to the hair. So the opponent suggests that if the reporter want to test if this is correct or not, you need to scale the weight of the hair to make sure if it is actually the hair water comes inside to the hair. And we believe that accuracy is to compare the result with prediction. It is different. It is different from the precision, and also the reporter told us about. So the opponent spend a lot of time in discussion to clarify what is different between the precision and also accuracy. And we believe that we should put several humidity to test if the distribution of vapor in a tank or space is the same or not. Not just use a chamber. And about alcohol, and we know that because the hair is a protein, and alcohol will certainly harm the hair. So the opponent didn't agree with the report this time. Thanks.
Thank you. Now the reviewer.
A question to the reporter. Why do hydrogen bonds form within the hair structure?
Why? Because
Yes.
the alpha structures have to form with the between the amino acids. We have like both parts of amino
Yes,
acids.
but why
and
do
then
they form between the amino acids?
Yes, between the amino acids.
Okay. Do you think that hair's quaternary structure contributes at all to its elongation properties?
I'm sorry?
Do you think hair's quaternary structure contributes to its elongation properties?
I think that the most relevant interactions are in these primary structures where we see the interaction of water molecules with the.
So you think it's most relevant in the primary structure of hair?
Yeah, in the most primary.
In the primary structure.
This is the secondary structure of.
Yeah, in the secondary structure or the
the
primary?
alpha structure.
Secondary.
Is
Yes.
most
Okay,
internal
secondary.
structure.
Yes. Opponent, what do you think? Do you think hair's quaternary structure contributes to its elongation properties?
I think you need to consider rolling bonds, not only hydrogen bonds.
Yeah, okay, okay. Do you think that the elasticity of the hair changes as a function of varying parameters?
Yeah, the hair do have elasticity, but the elongation due to elasticity of the hair is not as great as the swelling of the hair with the
So the
humidity.
change length is more noticeable.
So it's less than our centimeter of the hygrometer, so it's not big deal.
Okay, what do you think? Do you think the
opponent
elasticity...
elasticity will change.
Okay. How many hairs did you use for each trial?
For each trial, like
Yes,
experiment of
like did you have a single hair in your hygrometer, or did you have multiple?
one hair. So
One hair.
just have one hair.
What did you directly measure using your hygrometer in your testing? How did you convert those to relative humidity values?
Yes, we've used the operation shown in the presentation. So the relative humidity as a function of the number of strips that pass through the sensor, and that's
Yeah, okay.
how we got the relative humidity.
Why is curly hair more optimal for hygrometer using straight
Yes,
hair?
the curly hair has this structure because of the distribution and concentration of hydrogen bonds, and with it, we have this different
Yes.
structure. So,
Opponent, why do you think curly hair?
Curly hair and the straight hair has different structure,
Yes.
and the report told us maybe it's the different coefficient.
Okay, yes. Did you note any permanent deformation of the hair during the trials?
permanent deformation.
Yes.
Yes, the expansion of the hair that we in your investigation are permanent.
They're permanent. So
Yes.
you never notice the hair return to its original length after you return the humidity?
If we return the humidity, we have a certain hysteresis, but it's
It's still
contracts back
Yes.
with a certain hysteresis.
Did you investigate the effect of temperature on response time or accuracy?
We've maintained temperature constant. The DH sequencer also measures temperature and we've maintained it
Your
constant.
temperature is constant?
Thank you.
Okay, my name is Daniel Campbell and I'll be reviewing problem number 11, hair hygrometer. So we saw a number of positives from the reporter, mainly that he had strong explanation of the hair structure at the microscopic level and he had a good correlation between the variables and mathematical formulas. And I thought that was very positive in showing the effect of varying parameters on the length of the hair. He had a large number of trials conducted and so I commend him on that. That improved the validity of his results. I think he could have explained more the fundamental concept of why the hair expands and contracts with humidity. And I think I was a bit unclear on his explanation of why hydrogen bonds form. I didn't think he went into enough detail about why the bonds form. For example, the different electronegativity of the atoms and therefore positive and negative dipoles that form the hydrogen bonds and therefore they influence the length of the hair. I thought he should have gone into more detail of that. He could have gone into more detail of the protein structure of the hair, specifically going into the tertiary and quaternary structure, which I think is relevant because hair makes a supercoil structure in that two alpha helical hair structures wind themselves by their left side, and hydrogen bonds do form in this quaternary structure, as well as ionic bonds in dispersion forces. So I think this was actually really relevant, and I think he admitted that, even though it has a large effect. Some of his experimental weaknesses, he used different hairs across multiple trials, and therefore he has a different coefficient of expansion, which I think it leads to systematic error. And he only compared the accuracy of the hygrometer to a single humidity probe. So he has a very small comparison to another hygrometer, and if that hygrometer is less accurate than he proposed, his results would be less valid. Some positives in the opponent, he identified certain key flaws, such as the lack of explanation of the hair's actual mechanism of elongation, but I think he should have pushed that point more. He asked about it right at the start, but only very briefly. He also identified the key flaw that the reporter did not significantly explain the structural differences of the different types of hair. And some of the negatives, he did not understand Fick's law of diffusion in his line of questioning earlier in the presentation when he's discussing the curve of the relative humidity versus time graph, as he asked about the correlation between the variations in the difference in partial pressure and the rate of diffusion. And he discussed the largely irrelevant factor of transfer time of data from experiment to computer, which I thought was not relevant to the presentation. The mechanism of hair elongation, I think that's, I agree with the opponent on that point that he raised. The reporter has not sufficiently explained why the hair elongates. And he only mentioned the hydrogen bonds, but did not state the state interactions between the secondary, tertiary, and quaternary structures. On the point of the discussion of transfer time of data from experimental setup to computer, I agree with the reporter in that this is very irrelevant. And his definition of accuracy, I agree with the opponent, clarification was required, but I think the reporter did test both in that he had the error bars, which shows that he did test the precision, and he also showed the comparison to his other hygrometer, which compares the accuracy. I think some missed points of the discussion, the opponent should have brought up the change in hair elasticity. I think that's actually vital, and it makes a definite impact on the length of the hair. I think he should have brought up that different hairs were used for different trials, and he should have discussed more the mechanism of elongation. And he had little explanation on the formation of the hydrogen bonds, and he did not push that point. So in conclusion, I think experimentally and mathematically, the reporter had a very strong presentation, but I think qualitatively it needed quite a bit more qualitative explanation, especially on the protein structure of hair. And I think the opponent brought up some very relevant points. Thank you.
No, please.
So in relation to the final considerations, I would like to find some point of the opponent. He said that the mechanism about the mechanism of the elongation of the hair, and I think that this mechanism was well explained in my qualitative analysis. I gave the interactions between the water vapor and the hydrogen bonds, and as the water vapor has the predominance, and in the hydrogen bonds we have its preference in entering and then swallowing the hair. In relation to accuracy and precision, again, if I don't investigate precision and investigate just, it's really hard to just investigate accuracy. So we would have a great deviation of our measurements and we would not see accuracy. So as we increase the precision, we can then increase the accuracy. So that's why I investigated both, as pointed out by the reviewer. And in relation to the alcohol interference, as I said, this is a normal procedure for everyone who's doing a hair hygrometer. In all the papers, if you read, you use alcohol, and in our opinion, the mixture we have used doesn't harm the hair, and it was enough to clean the hair and remove the oil, the layer of oil, as we've said. In relation to the points of the review, he said about the different hairs in different trials, but again, the coefficient beta was tested with 10 different hairs, and with it, we've taken the standard deviation of these 10 hairs of the same color of the same person, and with it, with this standard deviation, we've measured the error of the coefficient beta. So when we use different hairs, the error, the deviation of the coefficient beta is already in the deviation we put in our coefficient. So I think that this point is negligible. In relation to the formation of hydrogen bonds, as I said, like when we have the alpha structure, we have the free orbital in one of the parts of the amino acids, and with it we have a great tendency to form these hydrogen bonds. But in my opinion, in the presentation, I thought that it was more didactic and more precise in this way to try to explain from the formation of the hydrogen bonds with water to the elongation of hair. So that's all. Thank you very much.
Thank you. Maybe I shall ask the first one. Show me. Don't switch off the reporter. Reporter, don't switch off. So show me the plot with the time dependence. Ah, I see, I see. No, now please stop the watch and we shall start.
Yes, here, this spot.
Yes, this one. What does it mean, humidity?
Yes, we have here the theoretical.
The sense of the humidity, please.
Yes, we have here the theoretical curves of the relative humidity and function of time that we
Relative humidity of what?
of the this is the relative humidity measured by our hygrometer.
But how, I can hardly imagine that you measure relative humidity of the hair. Can you? How can you do it?
No, yes, like
Explain, please.
the interaction, we have the entrance of water in the hair, and with it we have an elongation of the hair in this stem. So as more water is entering in the hair, we have a more increasing in this expansion, and with it the measurements starts to change here. Point
Well,
to
maybe
point.
this is extension, but not humidity.
No, this is relative humidity. It's already with the algorithm.
Can you discriminate absolute humidity and relative humidity, please?
Yes, absolute humidity is related to the absolute value of the vapor pressure inside an environment, and the relative humidity is this value of the absolute humidity divided by the maximum vapor pressure of water in this case.
And the next question, you use cooler to change humidity.
Ah,
What does it mean?
I'm sorry. Like I've used the cooler to try to distribute the humidity to make the humidity more uniform in the chamber. It doesn't affect the humidity in the chamber. It doesn't add water or.
Thank you. Other question? Yes, question.
You did mention about the hysteresis, yeah?
Yes, yes.
What was the hysteresis and how it was changed during the
Yes.
measurement?
In relation to the hysteresis, as I said, I've changed the hair in all of my experiments I've done. So as the hair is a plastic material, so we have these effects of hysteresis, and then we try to change the hair to try to avoid this effect in our measurements.
So how you ensure that you use the same hair?
I'm sorry.
Each time, each experiment you make once, yes?
Yes.
Using the one hair.
Yes.
So and next you did change the hair.
Yes.
And how you were sure that this is the same hair?
Oh yes. Again, the bigger coefficient, there is coefficient of hair growth expansion for each one of hair. We've measured with several hairs of the same person of the same time, and with it we've got standard deviation. So we know that the coefficient beta of these hairs that we are using are in this interval, this standard deviation that we've measured. That's how we've ensured that the coefficient beta
Thank you, thank you. Short question to the opponent. Do you know the word sensitivity? Sensitivity, do you know the word sensitivity? You talk a lot between accuracy and precision. What is sensitivity?
Sensitivity depends on its response time and how small it can test a little bit different humidity.
You mix the precision and sensitivity, I think. Next one.
I have a question for the reporter. Can you look at your slide 24? Am I right to understand this set of data as you calibrating
Again, the
calibrating
sense of the axis.
Yeah.
Yeah.
So, yeah. Go on. So you have an environment with 50% humidity,
Yes.
and how did you know it was 50%?
That is your actual measured humidity with the DHC22.
Okay, and then what do the other brown plots
Ah,
mean?
These are the measurements of this same environment with our hygrometer.
So is this a calibration?
Thank you.
Thank this
Thank you
experiment
very much.
very-
Our time is
I'm sorry.
unfortunately. Now take your places, please, and we shall grade. Who shall it come from myself?
Yeah.
Okay. Now, show please the grade for the report. So 6, 6, 4, 7, 6. And 1 for the opponents. 5, 6, 6, 7, and 6. And the last one was the review. Please. 6, 7, 6, 7, 7. Thank you. Now can we argue our marks? The lowest mark for the report, let's see.
And that's what I was the lowest mark, because it's like, I think that you had a very nice tools for to start doing the experiments. That's what I was expecting. I was expecting the comparison. Actually, you was avoiding these mysteries. I don't know why. Because at that point, I would like to start this experiment. And that's what was very important for me. Because everything, okay, it's a biology, whatever, is okay. But you set up your system, and then you start to experiment. Since you have system, when you change all this is like your sensor. Here is your sensor, and each time you are changing your sensor. So why you were doing this? I have no idea. And the hysteresis was like a major point of this. I was expecting that this hysteresis changes, going up, decreases. Then you have time for the reaction of your system, and there was nothing like this. Just one time you make like you put sometimes new sensor, and then nothing. You have temporary system sometimes.
No, and the logic.
Yeah, so like I think that's a very difficult problem, and I was impressed with what you did with it. I was wondering if I was going to see anybody mathematically model that problem. I was impressed with what you did. I thought I thought you possibly didn't quite go as far as like in the problems asking you to. You sort of showed graphs of how the response time and that changed, but you never really went as far as stating what your accuracy actually was, like how much up and down, what is the percentage, what's the uncertainty actually in it, and how long does it take to respond? Just some clearer statements of what you had actually achieved. I thought I thought it was a very good job.
According to the opponents, I have put the lowest mark, right? Because you talk a lot about the accuracy and you say precision. And there is quite adequate word, sensitivity. This is the difference between sensitivity and accuracy or precision. You see, and you have a lot of time speaking about it, but it didn't take, not discuss so much the results in itself, and the plots of for myself. I put the mark maybe higher than I want in myself, but this is some positive action maybe. But I don't understand all of them. Really. But you should make it. This is the role of opponent, the main role of opponent, to discuss the results, but not the details, small details. And the last one for the review, it was homogeneous, 6, 7. If anybody wants to see it. I like it, but also I have some comments negative comments to your review. You use some maybe words and phrases which are not, we're not sure corresponding with the report here. So computer reviewers or time dependence with computers corresponding accuracy of Hydrometer. So this is the. So if anybody wants to comment this stage in general.
I would just like to comment that I thought that was all around just a good fight. I made an absolute shambles of this from, so sorry if anyone tries to read this, but I really had time distinguishing between that, but those are something like across the board, it's like just a general, like, rewriting that global lens. Yeah.
Well, thank you. Let us thank all the